We're going to look at some solving exponential equations using the inverse property. So we'll have a number base in example 1, and we'll have a base of e in example 2. So basically using the inverse property, we first need to get the base by itself, and the base is going to be the number that has the exponent attached to it. So my goal is to isolate this 4 to the 2x plus 1, so I need to get rid of these other numbers. So first thing I'm going to do is I'm going to go ahead and subtract 4 from both sides. So that's going to give me 3 times 4 to the 2x plus 1 is going to be equal to 18. I still need to get rid of this 3. It's being multiplied, so I'm going to go ahead and undo that by division. I know it's really tempting to distribute, but you definitely do not want to do that. So divide each side by 3. I don't know why I keep writing 8. It should be 3. And I'm going to be left with 4 to the 2x plus 1 on the left-hand side, and 18 divided by 3 on the right-hand side gives me a 6. Now that I've got this base of 4 by itself with its exponent still attached, I need to now undo this. So the inverse property says I want to identify the base and then take the log of that base of both sides. So I'm going to take the log base 4 of both sides of my equation. So log base 4 of 4 to the 2x plus 1 is going to be equal to log base 4 of 6. Again, whatever I do to one side, I have to make sure to do the other side. So our inverse property says log base 4 of 4 undoes itself. So we're just left with the exponent of 2x plus 1 on the left-hand side. And on the right-hand side, this is where I'd want to go ahead and use the change of base formula. So I'm going to rewrite this as log of 6 divided by log of 4. And I'm going to use my calculator to evaluate that. So that'll leave me with 2x plus 1 still over here is going to be equal to about 1.292. And then I can go ahead and solve for x. So subtract out 1. That will give me 2x equal to 0.292, and then divide each side by 2 to get the x by itself. So our x value is going to be approximately 0.146. And again, I can go back and check to see if this seems reasonable in my original equation. So our second example is with the base of e. So again, my base of e to the x minus 1 is what I want to get by itself on one side of the equation. So I need to undo the numbers around it. So I'm going to go ahead and add 2 first. So that's going to give me 10 times e to the x minus 1 equal to 34. And then I need to get rid of this 10. So I'll go ahead and divide it out on either side. So that will leave me with e to the x minus 1 is equal to 3.4. And then I need to undo this base of e. So it's a little bit different than the process in the last example. To undo base of e, I'm going to take the natural log, or the ln of both sides. So ln of e to the x minus 1 is going to be equal to ln of 3.4. Again, whatever I do to one side, I have to make sure to do the other side. So this ln and e, that's our inverse property that undoes itself. So we're left with x minus 1 on the left-hand side equal to ln of 3.4. I can use my calculator to get an approximation of that. That will leave me with x minus 1 is equal to ln of 3.4 is about 1.224. And then I need to get the x by itself, so I can go ahead and finally undo that -1 by adding it to both sides. So our x value here should be about 2.224. And again, I can go back and substitute that into my original equation just to see if it seems reasonable.